Yeah, Vishnu. Okay, I will call you tomorrow. So we were discussing something. Can anyone tell me which topic we were discussing? I think we need to start from 2G, right?
Yes, sir.
Okay. So we have gone through 1G. Okay. We have gone through 1G. So where in 1G FDMA was used. Here the simple thing is, so entire frequency is divided into frequencies, several frequencies. So total in the system, there are 832 channels. Okay. So in this case, one user per one channel, one user per one channel. Got my point? Okay. So when it comes to 2G, right? In 2G, TDM, there was North American TDM before this. So purely digital. There is a North American TDM. Of course, when it comes to commercial, it is used in GSM. Nikhil, very basics are going on. I
Okay,
think
okay.
you no need to worry. Okay.
Yep.
Still, we
Okay,
didn't started the main topics.
okay.
In
Thank you.
3 classes, we need to discuss very basics. Okay.
Yeah. Okay.
So what exactly this TDM? So here we know frequency is very costly. So that's why if a frequency is assigned to one subscriber or one user, then that will be remain in use. So others can't use. So that's why they gone for the TDMA. Simply the same frequency will be divided into time slots. Time based allocation means channel here channel allocation is channel allocation will be on time. It's a time slot. Okay. Slot 0, slot 1, 2, 3, 4, and so on. Well, very smaller time. This is actually a smaller means 577 microseconds. Very smaller. So like this, 8 slots means 8 slots combinedly. It is somewhere around 4.3 milliseconds of frame duration. So then in GSM, that is 2G GSM. So these both FDMA and TDMA used. FDMA plus TDMA as used. Okay. So this look like simply again here GSM again government has assigned 25 megahertz to these services, 25 megahertz, right? But the channel size, right here, it became little digital. GSM is completely digital. We know that whenever we talk, that will be in the form of analog. This analog should be converted to digital. So analog to digital conversion, analog to digital conversion, right? We'll get to zeros and ones. Right, there will be some manipulation, there will be some right to provide the security, to provide the security, to provide the security, these bits will be manipulated. Means a series of stream will be added, extra bits are added, so that we call it as interleaving. Voice bits will be there, along with those bits interleaving bits will be added to right to make little complex, so that if anybody wanted to catch the communication, right, they cannot catch easily. Of course, definitely there is a there will be ways to capture the communication, but right, definitely they have to struggle a lot. It is not like 1G. 1G, if I can tune to particular frequency, I can easily catch the communication. But in 2G and digital, little uh, hard to uh, catch the communication. So here also 25 megahertz assigned, right? You can see these are the standard second generation IS 136, IS 95. So this is another form of CDMA. Then this is purely GSM. So here also 25 megahertz assigned to the telecommunications or 2G by the ITU. Okay, 25 megahertz, right? Again, you can see this is a downlink. This is uplink communication. Okay, downlink communication and uplink communication. Downlink communication needs a separate bandwidth and frequency, and uplink communication needs separate frequency and bandwidth. So here 25 megahertz assigned, here also 25 megahertz. So in this case, the channel bandwidth, right, was designed 200 kilohertz, 200 kilohertz. In 1G, that is 30 kilohertz. Here it is 200 kilohertz, because the slot duration is very smaller, 577 microseconds. Few bits I can transmit it here, few bits, right? During the simply I can say this is my analog signal. So digital form of this will be discrete signal, I can say. Okay, discrete signal. So like this. So these will be rounded off to different levels of bits. 1, 0, double 1, right? 1, 0, 0. So like this means whichever dot is there, this will be taken as 100, right? Which is rounded off here. So simply I can say, if I wanted to convert it to digital, then this becomes somewhere 00, 011, then somewhere around here 001, and so on. So this conversion will take place. So these bits will be transmitted in time domain, which we discussed, a slot 577 microseconds. Okay, so this is analog to digital conversion. This digital data will be pumped through this 577 microsecond. So definitely this data rate is not enough for any communication. Not enough. So that's why what they have done, they have grouped several frames to write. For example, if I say this hello, let us take, when I say hello, it look like in this form, hello, then converted. So if let us take it is produced so many bits, so many means let us take 1000 bits it is produced. I cannot transfer 1000 bits. Administrator, who is this administrator? Okay, 1000 bits I cannot pump here. So means one user required more than one slot to transmit. Got my point? If I say 8 slots, okay, 8 slots are there, and each user will get one slot, user one, user two, user three. For example, this to transmit to 1000 bits. Here in 177 microseconds, uh, I can transmit only 157 bits, around 144, I think so. I forgot. Around 144 bits only I can transmit. You can see. So this slot is not enough to transmit 1000 bits. So group of slots are required. Means if I say this is one frame, next frame, next frame, next frame, means it required at least almost here I can say 1000 bits, means at least 7 to 8 frames are required. So that's why 200 kilohertz taken. I'll show you how this conversion happens. Okay. I hope you are able to follow me, right? Hello.
Yes, sir. Yes, sir.
Right. So here 25 megahertz divided by 200 kilohertz. How many channels we will get? 125 channels we get. We usually call ARFCNs. Absolute radio frequency channel numbers. Absolute radio frequency channel numbers. Okay, absolute radio frequency channel numbers. Clear? So, but right, definitely 125 channels was there, but one channel is given for the God band. Given for God band. What do you mean by God band? What do you mean by God band? So here the frequencies 890 to 915 is there, right? So this side might be assigned to some other communications. Maybe this side might be assigned to a different communication. So definitely there should be a God band between these two different services. Means this frequency is given to cellular service. Maybe this is given to some satellite services, or maybe railway services, some services. So this should not interfere with each other. So God band will be there. This side, God band, this side. So this God band, right, consumes one channel. So here only 124 channels. Finally, 124 channels. See, out of this 124 channels, for example, in India, 2G operators, right? Nowadays, we have 2 to 3 customers, sorry, 2 to 3 operators. But in 2007, 8 at that time, right, we used to have Reliance, Arcom, Tata Docomo, Virgin Mobile was there sometime, BPL Mobile was there sometime. Uh, a lot of mobile, lot of operators were there. Okay, so they used to purchase here channels. For example, Airtel purchased. Okay, Airtel purchased 7 channels out of it. Another company, Hutch was there. Hutch then became Vodafone, maybe 3 channels. So like this, Arcom was having right a lot of coverage at that time. They maybe they might have purchased some channels. Means out of this 120, right, different operators has to purchase the channels, and that is based on the again telecom circle, right? Telecom Karnataka circle, telecom Tamil Nadu circle, telecom Madhya Pradesh, or telecom Maharashtra circle. So right, depending on their purchase and where they wanted to use, BPL mobile was there. It was there in Mumbai and Pune only. Okay, so depending on their right usage, they used to purchase. Got my point? So here GSM, right? GSM uses underlying is one is TDMA plus FDMA. So if I take in terms of frequency and time plot, it look like this. Okay, so this is the frequency domain, and here it is the time domain. Got my point? Frequency domain and time domain. So generally, right? So here, how much frequency was? 25 megahertz frequency. Sorry, total bandwidth given to these services, 25 megahertz. So this 25 megahertz divided each of 200 kilohertz. So total 125. One is given for broadband. So each one is 200 kilohertz. So this frequency is further divided in time domain and further divided in time domain, and this channel allocation will be done in time domain. So I'm introducing slot and frame concept here itself. Okay. I hope you are able to follow me, right?
Yes, sir.
Okay. So usually how allocation will be done? So here it is 0, 1, 2, 3, 4, 5, 6, 7. Okay. Again 0 starts. 0, 1, 2, 3, 4, 5, 6, 7. Which means GSM, right? Each carrier, if I say 200 kilohertz carrier, if I assigned an antenna here, so it supports only 8 users, 0 to 7, which means 1, 2, 3, 4, 5, 6, 7, then 8. Okay, only 8 users at a time can communicate. Okay, so for example, as we have taken one example, that is 1000 bits produced from the word hello. Okay, so so here, right, this is subdivided into 144 bits. 144 bits. This each bits. For example, this hello word is transmitting from user one. U1 means user one. So user one is assigned here. User one is assigned here. So first 144 bits will be transmitted here. 144 bits. The next is 144 bits of user one can only transmit in the right same slot number 0 only. One more 144 bits here. Next, right after 7 again 0, 144 bits. So communication will happen like this, right? Digital communication is always a discontinuous communication, but you can see what is the time duration, 577 microseconds, even frame 4.3 milliseconds, around 4.3 some around milliseconds. Our ear senses cannot identify the communication is a discontinuous communication. It is not a continuous communication like analog or analog. Okay, but our ear cannot identify this smaller difference, even though data comes uh, data comes as a parts, but human eye cannot recognize that smaller gap difference, at least seconds difference, ear and eye can differentiate. Clear? Hello? So here each slot duration is 577 microseconds, very smaller. So that's why GSM will provide you smaller data rate, very smaller data rate. Okay, and this group of 8 slots, I can say one frame. Clear? Is anyone have any doubt?
Can you repeat how 144 bit is transmitted here?
That is big story. Just forget about it. Okay. For now, you forget it. There is a lot of story. That's what I said. Right? So this 177 microseconds time slot. Okay. I cannot fit more number of bits here. Okay. I can fit only 144 bits, and there is a lot of story. We cannot go through that complete story. Okay. Because our aim is to go through 4G and 5G. 2G itself is a big course. 3G itself is a big course. Okay. Got my point?
Yeah.
2G itself is a, if you want to learn each and every corner of 2G, it takes again 3 months, more than 3 months. There you will have complete calculations, CB1, CB2, a lot of things are there. Just to understand it is prerequisite, right? To understand how communication, how capacity is increased from 1G to 5G. Just we wanted to go to that. Okay. So one base station has installed, which is given 200 kilohertz of carrier. Now you can see how, right? I was telling only 8 users. Okay. And each user voice is converted to analog to digital, which comes out to be 13 kilohertz. But the channel is a 200 kilohertz. Right? That's what I'm saying. So human voice will be around 3 kilohertz, 3 to 4 kilohertz. Right? If I speak little loudly, that goes up to 4 kilohertz. So that will be converted from analog to digital. Right? Around is also depends 9 kilohertz to 13 kilohertz. Right? You can see. So first user, second user, 8 users, and each user is filling in one particular slot. You can see. Okay. So still 13 into 8, we don't get this much, 200 kilohertz. Transfer simple word, so many bits are required. Is my voice clear, guys?
Yeah.
Yes, sir.
Hello.
Yes, it's clear.
Oh,
Yes.
right. So means like some number of bits are required to replay the voice at the receiver. I transmitted hello, right? It goes to the receiver to replay, right? Required number of bits or some required uh, number of bits, uh, means like 144 or 256 are required there to replay the same voice at the receiver. So that's why multiple frames, right, together transmitted. So here you can see almost 26 frames. 26 frames carries required data to transmit a basic voice. Okay, so this 26 frames, right, filling here, And also there is a modulation again. Okay, there will be a modulation in GSM. GMSK modulation is using in our LTE and 5G QPSK. It starts from BPSK, QPSK, 16 QAM, 64 QAM, 256, 512. People are testing with the 1024 QAM also. Means I'll explain. 10 bits per symbol. Data rate depends on the modulation scheme. So here GMSK even not 1 bit. Approximately we take 1 bit, but it is less than 1 bit. Let me write less than 1 bit per symbol, which means if you heard of some symbol, right? So symbols will be transmitted like this. So in GMSK, right, this carries less than 1 bit, less than 1 bit. But QPSK carries same duration, okay, 2 bits. 2 bits. Definitely, I can say same time duration. If I can pump more bits, data rate will be increases. So 1024 QAM is there. So if I say same pulse or 10 bits can be transmitted. See which one is the better. This will be the better because in the same time duration I am able to pump 10 bits, whereas here 2 bits less than 1 bit. So that's why here data rate will be very less, here little, then you can say uh, very good data rate. So that's why our 5G is going to provide you Gbps data rate. Okay, right? So you can see again this will be converted. So after multiplying this 26 multiframes, this comes out to be 270.8 kilobits per second. Then modulation GMSK will be applied. Then it after applying GMSK, it will be around 200 kilobits per second, which can be transmitted through a channel, whatever we discussed. Clear? This is how GSM communication happens. Got my point? Any doubts from this? So like this channel 1, channel 2, 124 channels, right? Fills total 25 megahertz. So out of this 124, different companies purchases different channels. Any doubts from this? Hello? Am I audible? Without your consent, I cannot go
Yeah.
for.
Yes, sir, you're audible.
Yes, yes.
Right. So then the leftover 2G, one more standard is there, that is CDMA. So all the technologies, you can say 4G, 5G upcoming is based on the actually CDMA. Okay. So here two drawbacks are there. Either we are able to allocate channel in frequency domain or especially in GSM time domain. Okay. Either we are using frequency domain and time domain, but still we are not able to use, for example, uh, I am expecting this is my GSM base station, right? I was telling that 8 slots are available. What is the drawback? Can anyone tell me here? 8 slots are available. 8 slots are available, but only one user is there. And what is the drawback? 7 slots are waste, right? In GSM, another standard was there. Of course, here still it is there, standard. Another standard, what is that? GPRS, no? Right. So with the introduction of GPRS, for example, this fellow wanted to download 1 MB file, let us take. 1 MB file he wanted to download. 7 slots are free only. This fellow, only one fellow is there under that base station. Okay. Right operator has installed in some place, one base station. Unfortunately, let us take everybody left that place. Only one user is there. Right? How it helps? 7 slots are free, but this fellow can occupy only one slot. Is this drawback or not? Bandwidth waste, right? 7 slots of bandwidth is free, but not able to use. So it takes longer duration of time to download 1 MB file with the GPS. Okay, people thought if this is the case, then definitely we are not able to use the total available bandwidth. Then they came up with CDM. Okay, here slot is means like channel allocation happens based on a different dimension, not frequency, not time, a different domain. So which is called code based, code division, multiple access. Okay, so simply I can say that brought another dimension which is called code. So this is time, this is frequency. So simply this 25, for example, again here 25 megahertz was assigned. Okay, but the channel frequency is given 1.25 megahertz. Right here, the 1.25 megahertz. The major thing is voice quality as well as data transfer. Okay, so then what they have done, this 1.25 megahertz can be assigned to a single user based on, means like if 100 people are there, let us take 100 users are there, this 1.25 megahertz, not technically 100 users, it is only 64 users, then this 1.25 megahertz can be assigned to all of them. If only one user is there, yes, 1.25 megahertz can be assigned to a single user. So effective utilization of bandwidth compared to 1G and 2G. Effective utilization of bandwidth. So let me write a simple code-based allocation. So for example, let's have an example. I know English, I know Telugu, I know Hindi, I know Tamil. Just for example, when I talk in Telugu who are there in the call or who are there in the meeting, Telugu people can decode easily. They can understand. When I talk in Tamil people can understand. When I talk Hindi people can, those who knows Hindi, they can understand. And when I speak uh, English, those who knows English, they can easily understand. Which means I am a base station. You are all mobiles decoding the signals based on the code. So here Telugu is a code, Tamil is a code, Hindi is a code, English is a code. So like that transmission will happens. For example, so this is the bandwidth of a channel, bandwidth of a channel. So here, mobile one, I hope you got my example right,
Yes, sir.
right?
Yeah.
So let us take 5 mobiles are there. Okay, mobile one, mobile two, mobile three, mobile four, mobile five. For example, this base station is transmitting data to only 4 mobiles, right? Definitely here mobiles should search for their data when this bandwidth comes to them. Bandwidth means, like you can say, a frame. When they receive frame, then they search the data. For example, so this portion is assigned to one user, this portion is assigned to one user, this portion is assigned to one user, and this portion is assigned to another user. So for example, this is user one. So usually these users will be assigned code, code one, code two, sorry, code one, code two, code three, code four, code five. Okay, code one, code two, code three, code five. Right. So now, whenever my base station wanted to transmit data to user one in this area, this will be convolved with the code one. Okay. So then when it wanted to transmit data to user two, then it uses the code two. User three, code three. User four, code four. Okay. So now it is transmitted, right? Then this bandwidth once reached here, okay, all you, including five, if 10 users are there, 10 users, they search for their data in the bandwidth. So this you can say frame, right, transmitted on channel. So now once this bandwidth, right, received by this receiver, what it do, it starts searching data. How it will search? Its code is one. What it will do, it checks, is this is my data transmitted in this area? No, because the code is three. Okay, right, it is not convolved, so no data, because it is searching with code one, so not. So then let us take entered here, code two convolved with code one. No, not data is not transmitted in this area. Let us take here code four convolved with code one. No, right now you entered here. So here code transmitted with data is transmitted with code one. When both matches, there will be a data. So in, right, means like one by one it search from here, this will be code data. Got my point? So for example, user three, okay, user three started searching here. Yes, directly user three convolved with user three, code three, then there is a data, right? It will again search, it will again search here also. There is a possibility my base station might be transmitted data not only here, maybe here again. Okay, so then what it will do, it search two, right, then three, no, then entered here, data is transmitted with code convolved with C3, no data, then enters here, data is transmitted with code 1, then convolved with C3, no, this only this UE got. Now let us take a special case where this UE means this mobile is also, UE means mobile here, okay, user equipment, user Okay, got my point? Same theory, just they transform to 4G and 5G. Okay, so here this user 5 tried with, right? Here data is transmitted with C3 converted with C5, no data. Again here C4 converted with C5, no data. Right, C2 convolved with C5, no data. C1 convolved with C5, no data. So then this mobile decides that, oh, in this frame I didn't got data. This my base station hasn't transmitted any data to me in this. Maybe this frame 1, if I say next frame 2, next frame 3, and so on. Every time whenever a frame received by the mobiles will search their data inside that frame. Okay. For example, one train has arrived in a particular railway station. If right, someone is waiting for someone who is right expected to deboard the train in that particular station. If this guy who is waiting if he doesn't have any particular information, he only have the information that fellow comes, no train name, no time, just go and pick up, one guy comes and he drops on that particular station. And what he will do, he will search in every body, he search in first train every body for that fellow, next train every body, next train every body. Sometimes, right, he may, if he finds, yes, if he finds someone who is looking for, right, his job is done, right, first train gone, second train is gone, right, you can take this train or simply you can say bogies of a train, you can take it as a frames, each frame, the box. Okay, means the mobile's job is mobile search for its data in a particular channel by sequentially searching by using code. So that is code division multiple access. Okay. So here one scenario, here 4 users are there, bandwidth assigned among the 4 users, but only one user is there. Only one user means 5 users are there, right? These 5 users may not be connected. We don't uh, we don't we may not in connected mode always. Okay, I switched on my mobile, now I am not using my mobile, just I switched on and I kept there, I'm not using, there will be no data transmission. For example, only one mobile is downloading some 10 MB data, just take it as, and all others are just switched on and they kept idle. So then definitely this entire bandwidth can be assigned. If I take this user 3, u3, right, convolved with c3, entire data will be transmitted to this particular user. So that definitely data download speed can be more. Means I can say, if I take this is time domain, this is frequency domain. Time domain, frequency domain, I assigned in terms of code, so that entire time, if this fellow is using 24 hours, okay, and these others are not available 24 hours, not accessing uh, not accessing any data or not in call also, 24 hours this fellow wanted to download 10 MB, next 10 MB, or 1 GB, next 1 GB, 24 hours in time domain, and entire frequency is assigned. So that is the idea between that is the idea of CDMA. With the help of code, entire bandwidth can be assigned to a single UE or multiple UE depending on the connections. Clear? Hello.
Yes, correct.
Right. So we'll carry this forward tomorrow, right? How this is related to 3G and 4G, 5G.
Sir, I have one question. Like you said,
Hmm.
uplink and downlink.
Hmm.
So for uplink, so like we are using like 2G, so it
Ah.
will be send 900 frequency, right?
It can be anything. It depends. 800 megahertz band is there, 900.
Yeah.
I am not
So
sure
what
which
about
one you
that?
are using.
Yeah. What about the downlink? It will be same.
See here, two frequencies are there. Okay. So this is forward channel. This is reverse channel. Forward channel is a downlink here. Reverse is a uplink channel. Okay. Got my point.
Yeah,
So
but
here,
it's depend on the operator, right?
no. Where is operator? Here, this is fixed, right? This 124 channels and the frequency is fixed throughout the world. There is no operator. Operator has to purchase channels from 124. That's it.
Okay.
This right uplink band. So I'll write here in terms of this uplink band. This is my mobile. Okay. Or this is uplink. This is downlink. Uplink. This is downlink. So here 895 I think so. 890 to 915 is fixed. 890 to 915 fixed. Okay. For any operator.
So we will say like hello. So again, another side we will got the same like hello. So it will be the same frequency or will be the
Sir,
different?
here channels frequency range is same. This is entirely called a 900 megahertz.
Hmm.
Okay.
Okay. Yeah, that is enough.
This is totally 900 megahertz. 900 here how my 124 let me tell you 890 starts. Okay. Uplink 890.200 kilohertz is one channel, first channel. Okay. 890.400 will be the next channel, second channel. So until it reaches 950. This last channel will be 124 channel. Each channel is of 200 kilohertz. Now you got it.
Yes, correct. Thank you.
So if I say this might be purchased by Airtel, this might be purchased by Arcom, maybe this might be purchased by Tata. Now you got clear?
Yes. Thank you.
Any doubts further? Who is attending our work? No doubts, right? From GSM? Stepping stepping stones. These are all
So this video will be uploaded on the link, right?
all I will upload. No negative.
Okay. So when you will be share the link?
I already shared, na?
Recorded session already shared.
No. I given access to all. I think so. If anybody is not got, just ping me your mail ID. I'll give.
Okay. Sure. Thank you.
Okay. Okay. Right. We'll see tomorrow.